What if rain didn't fall down, but sliced through the air sideways? Not water, but razor-sharp glass, moving faster than a bullet, no warning, no shelter, no survival. And the strangest part, this is real. Picture yourself standing under a dark sky. You expect rain, maybe thunder. Then something hits the ground beside you and shatters. It's not water, it's glass. Now ask yourself, what kind of planet turns rain into a weapon? Because on this world, the air's never calm. The winds don't drift. They race across the planet at extreme speeds. And here's the surprising part. Those winds don't carry dust or sand. They carry molten rock. Let's simplify that. On Earth, rain forms from water vapor. It rises, cools, and falls. But here, the temperatures are so high that rock behaves like water. It melts, then it vaporizes, then it floats through the atmosphere. And when that vapor cools, it doesn't turn into liquid. It hardens into tiny pieces of glass, sharp, solid, dangerous. But here's the problem. Gravity isn't in control, the winds are. So instead of falling down, the glass is blasted sideways, constantly, violently. Imagine a storm where every drop hits like a blade. Now, imagine standing inside it. You wouldn't feel rain, you'd feel continuous impact from every direction. So how does a planet even reach this level of chaos? Because this isn't just extreme weather, it's a completely different system with different rules. Now, if you're enjoying these kinds of mind-bending science scenarios, make sure to subscribe, because we break down complex ideas into simple visual explanations every week. This planet actually exists, and it looks surprisingly beautiful. A deep blue world, almost like Earth from space. But don't let that color fool you. This is one of the most hostile places ever discovered. The planet is called HD 189733b. It sits about 64 light-years away from Earth, close enough for us to study, far enough to feel unreal. At first glance, it looks familiar. That deep blue color resembles Earth's oceans. But here's the shocking truth. There are no oceans there. That blue glow comes from something far more dangerous. A thick atmosphere filled with silicate particles, tiny fragments of material that can turn into glass. Now ask yourself, what happens when extreme heat meets particles like that? Because this planet is incredibly hot. Temperatures rise above 1,000 degrees Celsius. That's hot enough to melt rock. On Earth, we only melt rock inside controlled furnaces. Here, the entire atmosphere behaves like one. And this is where things change. That vaporized rock doesn't stay a gas forever. As it moves through slightly cooler regions, it begins to condense. But instead of forming liquid droplets, it turns solid, into glass, sharp, dense, dangerous. But here's the problem. This planet is not calm. Winds here can reach over 8,000 kilometers per hour. That's several times faster than the speed of sound. At those speeds, nothing falls straight down. The glass is pushed sideways, constantly, like a global sandblasting system. Except the sand is razor-sharp glass, and suddenly, that calm blue color means something very different. But this raises a bigger question. What kind of environment creates winds this powerful in the first place? Rain usually means water, something you can feel, something familiar. But what if rain was made from rock, turned into glass, and instead of falling down, it sliced sideways through the sky? On Earth, rain follows a simple cycle. Water heats up, it evaporates, it forms clouds, then it falls. It's stable, predictable, almost boring. But on HD 189733b, that same idea exists, with one critical difference. There is no water cycle. Instead, there is a rock cycle happening in the atmosphere. Here's how it works. The planet orbits extremely close to its star. So close that temperatures rise above 1,000 degrees Celsius. At that level of heat, rock cannot stay solid. It doesn't even stay liquid. It turns into vapor. Yes, rock becomes gas. Now, imagine an atmosphere filled with vaporized minerals, silicates floating like invisible clouds. But here's where things change. As this material moves around the planet, some regions are slightly cooler, not cold, just less extreme. That small difference is enough. The vapor begins to condense, but instead of forming liquid droplets, it hardens instantly into tiny shards of glass, sharp, dense, dangerous. So now you have something that behaves like rain, but made of glass instead of water. But here's the problem. Gravity is not in control. Wind is, and not normal wind. We're talking about speeds over 8,000 kilometers per hour, faster than a jet, faster than sound. At those speeds, nothing falls straight down. Everything gets pushed sideways. Imagine trying to pour water during a hurricane. Now multiply that force several times. That's why the rain doesn't fall. It slices. A constant horizontal storm moving across the planet. And this leads to a bigger question. What kind of planet creates wind so powerful that even gravity loses control? What if wind wasn't just strong, but unstoppable? Not gusts, not storms, but a constant force moving faster than sound and carrying razor-sharp glass with it. To understand this, you need to look at how the planet behaves. HD 189733b is tidally locked. One side always faces its star. There is no day and night cycle, no rotation bringing relief. One side is permanently heated, the other side stays much cooler. Now, ask yourself this. What happens when one side is always burning and the other is not? You get imbalance. And nature always tries to fix imbalance. Heat begins to move from the hot side toward the cooler side. At first, it might seem like simple airflow. But here's the problem. There is nothing slowing it down, no rotation, no stabilizing system, so the air accelerates, faster, stronger, more extreme, until it becomes something else entirely. These winds can reach speeds over 8,000 kilometers per hour. That is faster than the speed of sound. Think of a jet engine. Now imagine it stretched across an entire planet and it never shuts off. Now add one more element, glass. The atmosphere is filled with tiny, sharp particles. So this is not just wind, it is a continuous planet-wide storm of glass, like a sandstorm, but far more dangerous. Now imagine being inside it. You are not just pushed, you are constantly struck from every direction at speeds beyond anything on Earth. But here's the twist. These winds never slow down because the temperature difference that drives them never disappears. The system feeds itself endlessly, and that raises a much more serious question. What would actually happen if anything tried to survive inside this environment? Let's take this one step further. What if you actually tried to land on this planet? Not observe it, not study it, but stand there. Would you survive even a single second? Imagine descending through the atmosphere of HD 189733b. From far away, it looks calm, a deep blue sphere glowing in space. But as you get closer, everything changes. The temperature rises rapidly. Within moments, it exceeds 1,000 degrees Celsius. That is hot enough to melt many metals. Now, think about this. What happens to the human body at that temperature? You would not feel warmth. You would experience instant, overwhelming heat. But here's the problem. You would never even reach that stage. Before you get anywhere near a surface, something else hits you first. The winds. These are not storms like on Earth. These are supersonic flows of air. They move faster than sound. Imagine being caught inside a jet engine. Now imagine that force coming from every direction. You would not fall straight down. You would be dragged sideways, completely out of control. And then comes the next layer, the glass. Tiny, sharp particles moving at extreme speeds, not falling like rain, but blasting across your path like a continuous stream of blades. Each impact adds more damage, constant, relentless. But here's the twist most people don't expect. There may not be a surface at all. HD 189733b is a gas giant. That means there is no solid ground waiting below, no place to land, no stable point to stop, just deeper layers of atmosphere, hotter, denser, more extreme. It is like falling into an endless storm with no bottom. So even if you could survive the heat, the winds, and the glass, where would you even stop? And that leads to a bigger realization. If one planet can be this extreme, how many more are out there, waiting to be discovered? From space, this planet looks calm, peaceful, familiar, a deep blue world glowing like Earth. But what if that beauty is hiding something dangerous? When astronomers first observed HD 189733b, one detail stood out immediately: its color, a rich, deep blue, almost identical to how Earth appears from space. And naturally, that leads to a question. Could it be similar to our planet? But here's the problem. That color is completely misleading. On Earth, the blue color comes from sunlight interacting with our atmosphere. Short wavelengths of light scatter more easily, creating the blue sky we see. Something similar is happening here, but the materials are very different. Instead of air and water droplets, this atmosphere is filled with silicate particles, the same material that forms glass. These particles scatter light in a way that produces that same deep blue color. So from a distance, it looks calm, almost inviting. But the reality is the opposite. There are no oceans, no clear skies, no stable weather, only extreme heat, violent winds, and constant storms of glass. Think of it like seeing a calm blue ocean, then realizing it is actually a storm you could never survive. That is what this planet really is, a visual illusion. And here's the twist. Most planets we discover are seen from very far away, just small points of light in space. We judge them by their color, their brightness, their appearance. But how many of them are hiding extreme conditions beneath that surface? How many beautiful worlds are actually dangerous? Because once you start looking deeper, you realize this planet might not be unusual at all. And that raises a much bigger question. What if this planet isn't rare at all? What if worlds like this exist everywhere, just waiting to be discovered? Because once you look beyond Earth, things get strange very quickly. HD 189733b sounds extreme. Glass rain, supersonic winds, burning temperatures. But here's the surprising truth. It is not alone. It is just one example of a much larger pattern. Astronomers have already discovered thousands of exoplanets, planets orbiting stars far beyond our solar system, and many of them are nothing like Earth. Some worlds are so hot that their surfaces are covered in molten lava, not small patches, entire oceans of it. Others may experience something even more unusual: diamond rain. Under extreme pressure, carbon can compress into solid crystals. These crystals can form and fall through the atmosphere. Imagine that for a moment, a planet where it literally rains diamonds. But here's the problem. We have only seen a tiny fraction of what exists. Our technology is limited. We can only detect certain planets under specific conditions. So what are we missing? How many extreme worlds are still hidden? There could be planets with storms beyond anything we can imagine, environments where physics behaves in ways we do not fully understand. And this leads to a powerful realization. Earth is not the standard, it is the exception. A planet with stable temperatures, liquid water, and predictable weather is rare compared to what we've observed so far. So ask yourself this: if the universe naturally creates extreme worlds, then how unusual is a planet like ours? And once you start thinking about that, you begin to see Earth in a completely different way. If you found this interesting, leave a like so more people can discover it. And let me know in the comments, do you think extreme planets like these are actually more common than Earth-like worlds? After everything we've seen, one question remains. Is Earth normal, or is it the exception? Because compared to these extreme worlds, our planet starts to look almost perfect. And maybe that is not something we should take lightly. Step back and look at the bigger picture. Earth is balanced, not perfectly, but precisely enough. Temperatures stay within a range where water can remain liquid. Weather changes, but it does not constantly destroy everything. The atmosphere protects life instead of tearing it apart. And here's the surprising part. This might be very rare. When we look at planets like HD 189733b, we see something completely different. Extreme heat, violent winds, Environments where survival is not just difficult, but nearly impossible. So what if those conditions are actually more common? What if most planets are chaotic, unstable, and hostile to life? That would mean Earth is not the standard, it is the exception. But here's the problem. We rarely think about that. We wake up, we go outside. We expect everything to work. Stable air, predictable gravity, comfortable temperatures. It all feels normal. But it only feels normal because it has always been there. Now imagine that balance starting to shift, not instantly but slowly. What if temperatures kept rising? What if weather became unpredictable? What if the systems we rely on stopped working together? That is the real takeaway. Planets like HD 189733b do not just show us how strange the universe can be. They show us how fragile stability really is. Now, if you're enjoying these kinds of mind-bending science scenarios, make sure to subscribe because we break down complex ideas into simple visual explanations every week. If you found this interesting, leave a like so more people can discover it. And let me know in the comments, do you think Earth is truly rare or just one example we haven't fully understood yet? And once you realize how rare that stability might be, you start to see Earth not as ordinary, but as something incredibly unlikely.